All right, welcome to today's Explainer. Today, we're unpacking a truly fascinating mathematical thought experiment by an author known as Shimon. We are going to explore a completely new coordinate system mechanism using division by zero. It's basically a framework that attempts to rewrite the rules of negative numbers by breaking math's biggest taboo. So if you've ever felt kind of constrained by the rigid rules of standard math, well, you're going to find this alternative universe incredibly intriguing to explore.
To really grasp why someone would want to just completely upend the rules of math, we have to look at the specific problem they were trying to solve in the first place. Think about this for a second. How do you explain the area of a square using negative numbers? In our standard coordinate system, if you try to calculate the area of a square using negative coordinates, you immediately run into a brick wall, because a negative times a negative equals a positive, right? So calculating a truly negative area is considered completely impossible. And this core limitation is exactly what sparked our author's insight in question, really pushing him to find a clever workaround. Let's move to Section 1, Questioning Conventional Coordinates, and see how this builds from those initial frustrations with the standard mathematical grid we all learned in school.
Now, what's really interesting about this comparison is the stark contrast. On the left side, you've got your standard coordinates. You move right or up for positive numbers, left or down for negative numbers, all marked by that super familiar minus sign. But look over to the right. In his proposed coordinates, a positive number is just expressed as a fraction over 1, and a negative number, it's expressed as a fraction over 0. Crucially, and this is a real game changer, he drops the minus sign entirely. He's proposing a system where the denominator itself, just the bottom of the fraction, tells you whether the value is positive or negative.
Okay, let's dive into Section 2, a new definition for division by zero, where things start getting really wild.
To make this whole system work, we have to suspend our traditional mathematical disbelief for a minute. The author introduces what he actually calls a forced definition. 10 divided by 0 is forcibly defined to equal negative 10. And the author openly admits that he is just forcing this rule into existence. We aren't looking at this to prove traditional math wrong or anything. Rather, we're just impartially observing how he sets up the foundational rules for his alternative mathematical universe. In his world, a 0 in the denominator simply means the output is negative.
Moving on to Section 3, Unique Calculation Rules. So the crucial point is how this functions in practice, because if you just force a rule, the whole system usually collapses, right?
And this brilliantly illustrates the how. How do you actually divide by 0? Well, step 1. You encounter your fraction with a 0 denominator. Usually, that's a mathematician's worst nightmare. So, in step 2, the author proposes this really neat trick. You borrow a 1 to calculate it normally. So, 10 divided by 1 is 10. Easy. But then, in step 3, because you borrowed that 1, you essentially have to pay the cosmic debt by flipping the sign of your final answer to a negative. So your positive 10 simply becomes a negative 10.
Which brings us to this absolutely defining quote from the source material. Dividing by 0 becomes a sign conversion. Within this specific thought experiment, division by 0 isn't about, physically dividing an apple into 0 pieces. It acts purely as a functional mechanism. It's like a toggle switch. It converts positive values into negative ones without ever needing to write a single minus symbol on the page.
Let's test this out in Section 4, multiplying negatives together. Now that we've got the sign flipping mechanic down, let's see what happens with multiplication.
Walk through this table with me, because this is where the magic happens. The first row is super simple. Positive times positive. 10 over 1 times 2 over 1 equals 20 over 1, which is just 20. Totally normal. Row 2 is negative times positive. 10 over 0 times 2 over 1 equals 20 over 0. And by the author's rules, anything over 0 means negative, so we get negative 20. Still makes perfect sense. Row 3 works exactly the same way, but pause for a second and look at row 4. A negative times a negative. 10 over 0 multiplied by 2 over 0 equals 20 over 0. And what is a value over 0 in this system? It's a negative. Therefore, in this specific framework, a negative times a negative actually equals a negative 20. He has completely bypassed the age-old rule that a negative times a negative must be positive.
Finally, we arrive at Section 5, Imaginary Numbers as Area. This brings our whole narrative full circle right back to the inciting problem.
Let's tackle that seemingly impossible task of calculating the area of a negative square. If we have a square with a side length as a negative value, which is expressed in this system as 1 over 0, we can just multiply length times width, right? 1 over 0 multiplied by 1 over 0. According to the multiplication rules we literally just established, this yields an area of 1 over 0. And because it has a 0 in the denominator, well, the final value is exactly minus 1.
Minus 1. I mean, think about that. In standard math,
The square root of -1 is an imaginary number. It's completely abstract. But in this author's specific coordinate framework, by radically redefining division by zero and removing the minus sign altogether, this elusive, abstract, imaginary number can actually be tangibly visualized as the physical area of a square.
And that leaves us with a truly provocative thought to wrap up today's explainer. If temporarily redefining the most basic, foundational rules of math, like division by zero, can unlock entirely new ways to visualize impossible concepts, what other conventional truths in our daily lives might be worth questioning? Sometimes looking at a problem through a completely impossible lens is exactly what you need to see a brand new solution. Thanks for exploring this wild mathematical framework with me today.